In this video, we're going to be talking about how to start up any projectile problem. Now, there are a lot of variations to projectile problems, but the two cases I'm going to present to you will give you a good starting point for just about any problem. So the first thing you want to do, no matter what kind of problem is, because projectiles are two-dimensional, which means they go horizontally and vertically, you want to set up an X and Y column, an X column for everything that's horizontal, and a Y column for everything that's vertical. The reason why you do that is because the horizontal motion has no net force. It's just inertia taking it to the right. So you're only going to use this formula in the blue box for the X side. On the Y side, because there's always the force of gravity acting on it and causing some imbalance in the vertical direction, there will be an acceleration. Everything in the red box will be used in the vertical column. So with that being said, we know for sure that we have an acceleration of negative 9.8 meters per second squared on this side. And if you have something with a horizontal launch, there is no vertical velocity in the beginning, okay? It does have a velocity, so it can be confusing because it looks like there should be a number here, but because there is no velocity directed downwards or upwards, you can say that there is no vertical velocity, but there is a velocity on this side. It is completely horizontal. That's basically the way you're going to start off with any horizontal launch. Now from there, typically what you're going to do is you would get one more number on this side or this side, and then you're going to find time, and then the time could be shifted to either side. So on the left side, if you have two numbers, you can solve for time, like such as your delta x and your v. Okay, this only has three variables, so if you have two known variables, you can go ahead and solve for the time on the left side. On the right side, you're going to need three known variables because everything in my red box over here has four variables in each of those equations. Therefore, you'll need three known variables. So you're going to have to get a third number, which might be something like a delta y, some kind of change in height, or a final velocity. And then you're good to go from there. Now for our second one, if you have an angle, the first thing you want to do is break it up into the x and y components. And what you're going to do from there is you're going to set up your x and y columns as usual, as you would with every problem because of the reasons I mentioned earlier. And then you're going to start off by doing a little bit of trig and get this adjacent side over here with your hypotenuse of 20. So for the x component, we are going to do Vx equals 20 times the cosine of the angle. And then for the y component, you would take 20 times the sine of the angle so that you get this opposite end over here. Okay, so after you do that, you're going to get your Vx and your Vy over here. You don't really have to call it Vx because I'm putting it in the x column, but this would be 17.32 meters per second. Over here, we do have initial velocity. This time it's being projected upward some, and that's at 10 meters per second. Okay, now from there, we still have an acceleration of negative 9.8 meters per second squared. And again, you want to grab some kind of number here or here so that you could possibly use time on either of these sides. So remember, time is the only thing that isn't a vector so that you could use it in either column. Now, if you're coming back to the same level it was launched at, you could say that your final velocity is negative 10 because it'll be the same velocity just directed downwards. So that's safe to do if the object lands back at the same level it was launched. Other than that, you're just going to have to read the problem and find some kind of additional variable, and then you could do some more solving from there. Okay, so I hope that was helpful in helping you getting started with just about any projectile problem. Thank you for watching and listening.